Right then, in this video we're going to have a look at the concept of data transfer. And what we mean by that is simply moving files from a computer to another computer. And we'll look at the various ways in which we can do that. First of all, let's have a look at you at school. So you're sat at a computer, and that computer basically has a wired connection. It comes out the back. Can't really draw it too well there, but there we go. And it goes into a device here, which is called a switch. And this basically, all the computers in the room are connected via wired connections to a switch. You may even see it on the wall of your classroom. There is a physical wired connection. Let's put this over here. Wired connection. Now, we're going to look at sort of data transfer speeds, I suppose as well, on this one. Now, at our school, we're a bit old-fashioned, unfortunately, and our cables are all made of copper. And you may be at a very posh school with fantastic new cables that have what we call fibre optic cables. The thing is that with either of these, I mean, this is fast, and this is even faster. But the whole point of a wired connection is that at this moment in time, and I'd be very specific, 2012, you tend to find that a wired connection tends to be the sort of fastest connection that you can get. And that's particularly useful if you have very large files. For example, if you've got something like high definition video, something like that, if you want to move it from point A to point B, and that's interesting because before we get there, well, when you save a document, where is it stored? Because it's not stored on the computer that you're working at. It's ultimately stored through another wired connection. I'll just do it simply here. This is supposed to represent a server, or the file server, I should say, in your school. Now, it might well be that you've got a switch with a connection to another switch before it gets to the file server. But it doesn't really matter. The whole point is that when you save a document, it's saved here on the file server. And that means you can sit at any other, I'll just draw an imaginary line out from here to another computer here. You can sit at any computer in your school, and you can download your work because they're all connected to the file server. And if you're doing something like high definition video, it's particularly useful to have a wired connection because it will download faster via a wired cable. There's nothing worse than sitting at school and going, oh, it's like a minute to download my file. So that's why we have this moment in time wired connections, because they are basically the fastest way of doing things. The thing is that wired connections are not the only way in which you can connect to your school's network. Many of you will have, smartphones and laptops and that you use in school and netbooks. And the question is, well, how do they connect? Well, they connect because cabled in to the switch will what we refer to as a WAP, a wireless access point. And what this means is that you can take your laptop, and because it has wireless technology, it can connect. Perhaps you get the idea. I'll draw a little dotty line. Ooh, dotty lines are not so good there. It can connect ultimately to the file server. So that's why when you're using a netbook at school, you're able to download work from your My Documents area, or whatever they use at your particular school. So as well as a wired connection, so put this as number one. Number two is that you can have a wireless connection. Now, wireless connections tend to be slower, but they do therefore give the ability for you to work anywhere. Well, I say anywhere. That's not strictly true. You have to be anywhere within range of a wireless access point. Okay? The problem that you can get is that if you've got lots and lots of laptops talking to a wireless access point, that can actually slow down the speed at which your file is downloaded as well. But there's also another way of connecting to a network, and that's via your smartphone. Now, your average smartphone is also going to have wireless ability. Okay? But as well as having wireless ability to connect to a network, your smartphone, you can use it anywhere, and you can get to Google. You can get to any website you like. And the whole point is that your phone will have a 3G, or possibly even not quite yet, but we're getting there with, I think it's called Everything Everywhere. At the end of 2012, we're seeing the introduction in the UK of a 4G network, and 4G is much faster. If you wanted to run, we talked about a moment ago, I talked about high definition video. If you want to run high definition video at the moment, you kind of best through a wired connection. It's okay through a wireless connection, but it's not really going to work that well through a 3G connection. But it will work through a 4G connection. So it does beg the question, when the 4G network is established, and indeed there are scientists at the moment already working on the 5G connection, it's probably about 10 years away, 10 years away, I'll put there. And I'll put mobile down here for point number 3. Now there's a point in the future, maybe there'll be no need for Wi-Fi, maybe there'll be no need for wired connection, maybe when your children get to school they'll just be using 5G connections for all of their mobile devices. These are great mobile because you don't have to be within range of a WAP. You really can potentially, with a mobile device, you really can work anywhere. You might argue that perhaps the cost might be a little bit higher if you've got a broadband, so you normally get these bundles, don't you, from your mobile phone providers, and they're not going to be as cheap because, let's face it, Wi-Fi I suppose normally is free, and at school it's completely free. But if you've got to have a 5G connection at this moment, or 4G, or 3G, isn't it? We're only on 3G at the moment. But you've got to pay for that service. Who knows what it'll be like in 20 years' time? The disadvantage, going back to a couple of things really, is that with these cables, there's quite a cost. Let's put this up here, wired connection. There's quite a cost involved in setting up a big wired connection. You've got to buy switches, you've got to buy cables, it can be quite unsightly. Unsightly? How do I spell that? Unsightly, that's supposed to be an H. Unsightly? Is that how you spell it? I think it is, isn't it? But you've got to have things like trunking, and sometimes if you're in old buildings, it's quite difficult to make that trunking sort of, not invisible is not the right word, but aesthetically pleasing, I think is probably what we're looking at. So those are the 3 ways in which you can potentially connect to a network and ultimately transfer your data. You could, through a 5G, connect to a file server. You can, through Wi-Fi, connect to a file server. You can, through cables, connect to a file server. Ultimately, it's about moving a file from here to either here, not too well drawn, or on there. There are different ways in which we can do it. So those are sort of standard ways in which we can use hardware to download files. Let's move on. I want to look at a couple of other things that I want to talk about. Ways in which you can move files from point A to point B. Well, you can do it via email, can't you? At the end of the day, it's nothing more than attaching a file. Attaching a file. You can send an email to somebody else, attach your document with it, and you're away. I guess the problem with email, if you like, is that sometimes you have file size limits. And that's twofold, really. Because I think like Hotmail only allow you to attach up to 20 megabytes. And of course, some people, I don't know if you have it in your school, you may have an inbox limit, so you can only have maybe 100 megabytes of data in your inbox. So if someone tries to send you a 20 megabyte file and you're already sitting on 90 megabytes of data in your inbox, it's going to be rejected. But email is one method in which we can move files from point A to point B. Another one, perhaps the naughty one, file sharing. Now, what we mean by that, I suppose the most famous site of all is the Pirate Bay. And file sharing is traditionally used, and let's be honest about it, I know people will say, oh no, you can share any type of file. But realistically, file sharing is normally used for things like music and software and films. But ultimately, the way that it works is that somebody has their computer, and on it they may have a file, a music file. I was going to draw a musical note, but I'm not very good at music. What does a quaver look like? Is it something like that, isn't it? That's not too bad. I'm quite proud of that. So let's say they've got a music file there. As long as their computer is connected to the internet, you are able, via file sharing sites, to download that music. You need to be careful on that, because I know a lot of you guys do that one. They're introducing something called the Digital Economy Act. Well, it's not introducing, it's been introduced. And there's a potential that if you download files illegally, eventually they may come after you, the people that own the music, to say, well, you downloaded it, give us the money. And that's starting to kick in. And people are getting bills. It's true. I'm not missing it. Do some Googling. It's called the Digital Economy Act. Have a quick Google of that. Another method in which you can share files or distribute files is via cloud computing. Now, traditionally, I guess the one that people are probably most aware of is Google Docs. And that's kind of funky because you can go into Google and they have their own little built-in sort of office applications, a word processor and a spreadsheet and a presentation thing. And that enables you to basically share a link to a file, and you share a link to a file, and then other people can download that file and they can work on that and they can re-upload it. And it's a good way, I guess the word we're looking for is collaborative working. And cloud computing such as Google Docs, and I shouldn't say Google Docs because Microsoft have their own SkyDrive. That's another one, isn't it, that you can use to share your files. There's things like Dropbox as well. I think this is like A Drive and stuff like that. But the whole point is that what you can do is cloud computing means you're uploading to a server somewhere in the world, and you upload to Dropbox, and then you can give someone a link to that Dropbox file and they can download it. This is a little better because we said about with emails, there are limits on the files sometimes that you can send. As I understand it, there's not really too much in the way of limits on the file sizes that you can have. Certainly, with the person that I make this for teachict.com, the way that we get my files of all these videos from my computer to the lady that runs the site is that I zip everything up. It's about 300-400 megabytes in file size. I put it onto, if I use Dropbox, and then she can download it at her end. I couldn't possibly attach that via email. I could set up a file sharing site, but I don't think that's quite a good idea. I mean, you should really Google some of the guys that have been arrested for file sharing. They're trying to extradite them to America and things like that. So, other things that I'd like to address here, and perhaps I should have got some graphics for this, is that yes, we can email, yes, we can file share, yes, we can use cloud computing, but we can actually use other forms of medium to distribute things. For example, the memory stick. If you want to transfer a file from one computer to another, you can simply save it to your memory stick, take that memory stick elsewhere, and then you could put it onto that computer and you can download it. So that's another way that you can distribute files using a memory stick. You could, if you wanted to, put it onto a CD or DVD. I suppose in some way it's a bit old-fashioned nowadays. I'm not too sure that many people would distribute files using CDs and DVDs. And don't forget, your CD's got a limit of just 700 megabytes. Not great for high-definition movies. DVDs, a single layer, 4.7 gigabytes. But to be honest with you, they're kind of costly, and often they're only sort of write once things, and if they're write many times, people don't tend to use them nowadays. I guess maybe I should have really done that one first of all, sort of going back in time. Another thing that you could use is the external hard drive. I'm sure you're aware they're basically like giant memory sticks, really. I mean, you can get a 3 terabyte external hard drive nowadays for around about, I don't know, £70 off something like eBuyer.com. A memory stick at this moment in time is 2012. I guess standard size is about 32 gigabytes. You can get 64, but let's be honest about it. 32 gigabytes is roughly 100 times smaller. An external hard drive with 3 terabytes is 100 times the size of a memory stick. So those are other ways in which we can move files from point A to point B. The last thing that I want to deal with on this particular video is the concept of bandwidth. Now, this is something that traditionally I've found with kids. They're aware of the word, but they don't really understand what it means. And if I say, "What's your bandwidth at home?" people will go, "Well, I don't know. I've got a 10 megabit per second connection with, I don't know, Virgin Media or someone like that, or BT or TalkTalk." And I guess they don't really understand what that actually means. The analogy that I tend to use is this. Well, actually, megabits per second. A bit, let's put up a bit there, just to let you know, a bit is the shortening of the word binary digit. What they do is take away the nary and lose the digi, and you're left with bit. There we go, see? And a bit is simply a naught or a one. And that's the basic, everything on a computer is stored in noughts and ones. So in theory, 10 megabits means that a computer can transfer 10, roughly, million noughts and ones per second, which sounds like an awful lot, doesn't it? Especially when I outline that a byte is made up of 8 bits. So say a single letter, let's take the letter, I don't know, C, in a computer is 0.10000011. So I don't know the maths, but let's say it's roughly a million, just over a million letters per second could be transferred. Sounds like an awful lot, doesn't it? But in fact, if you're downloading, for example, big bits of software, or you're playing games online, but you don't want to download lots of software, takes up lots of memory, and let's say you're downloading an application that is 100 megabytes in size. Well, I'm not going to go into the maths here, but that might take a few minutes to do on a 10 megabit connection. If you have a 20 megabit connection, you would expect that size the time to maybe half for that to download. So that's kind of where we're going bandwidth, but the analogy that I like to use is this one. Here's a postman. Yeah. Originally, I must confess, I did use an image of Postman Pat, and I want to actually dwell on this bit because I asked for permission to use the image of Postman Pat, and they got back to me, but they keep saying, "Oh, we'll let you know," and they haven't let me know so far. So I've decided that using the image of Postman Pat is not a good idea because that would be copyright infringement, and this is just a bit of open source clip art that I'm using here. So, and that's something for your projects that you do. Email people, ask them if you can use graphics. They'll reply, and then you can use that in your write-up in your R002 projects. But they haven't let me know, so I'm not using Postman Pat. This is his brother, Postman John. Anyway, the whole point that I'm trying to get at is I want you to imagine now that this letter that Postman John has here, is, well, I'm not going to call it a letter, I'm going to call it a packet. Because technically, when information goes from one computer to another via the internet, it's sent down the line in packets of data. And packets of data are just made up of lots of different bytes and bits and things like that. So it's sent down the line. Now, let's try and get this right. If you imagine that the postman he can deliver as many packets as he can fit through this letterbox that I have to draw on. So I don't know, maybe at a time, 20 letters could be delivered. So let's say 20 letters per second. That's a good way of doing that. Okay, so he's delivering letters, and they're going in bundles every second, but of course he can only fit, say, 20 through that there. Bandwidth, if you increase the bandwidth, it's like kind of opening the entire door. He can deliver as many letters as possible to fit through the door or the letterbox in 1 second. So, if the door is wide open, he can maybe deliver, I don't know, let's say 4,000 letters per second. And if you think about it, I think that ties in quite nicely with this concept of a C being represented by a letter. Do you see what I'm doing there? I should just pack it really, but a letter being represented by all of these. The whole point being is that in this particular example, he could only deliver 20 characters per second, and if we open the door up, he can deliver 4,000. So bandwidth, if you like, is nothing more than the size of the delivery delivery portal. Is that the right word? I don't know if portal is the right word. Actually, I don't know why I crossed it out. I think it probably is the right word. That's what we're trying to drive at. Bandwidth is nothing more than the amount of data that can be pushed down this line from point A to point B every single second. Hence, we have megabits per second. And that's the concept of bandwidth. I think I did quite a good job of that, actually. I'm quite proud of that one. Hopefully it makes sense to you. Anyway, bigger the bandwidth you've got, the more information can go down the line in a second. And ultimately, the quicker files can be sent from point A to point B. So the better bandwidth you've got, the quicker things can download. So let's have a quick recap. All the way back. Oh, there we go. You can connect while... Oh, look, my text has gone from over on this side. Well, it might not have gone, but I can't see it on my screen. We can connect via wires. We can connect via wireless. We can connect via 3G, 4G, 5G. If you're going to move documents from A to B, you can do it via the internet using email, file sharing, or cloud computing with things like Dropbox. If you want to do it physically, you could use memory sticks, CDs, external hard drives. And the key thing is that we've got the issue of bandwidth, and bandwidth is the concept of the size of the portal and the size of the delivery system. And the bigger the bandwidth, the quicker things will download.